Putri Damayanti. I'm from University Muhammadiyah Professor Dr. Hamka. In this video, I will explain about mathematics topic. The topic will be explained of probability. The first matter about definition of probability, the second matter about theoretical probability, the third matter about experimental probability, the fourth matter about probability of independent event, and the last matter about probability dependent event. So, let's get started. So, probability. What is the probability? Probability is a measure of the likelihood of an event to occur. Many events cannot be predicted with total certainty. We can predict only the chance of an event to occur, i.e., how likely they are to happen using it. Probability can rank in between 0 to 1, where 0 means the event to be an impossible one and 1 indicated a certain event. The probability of all the events in a sample space sum up to 1. The example, when we toss a coin, either we get head or tail. Only two possible outcomes are possible is H and T. But if we toss two coins in the air, there could be three possibilities of event to occur, such as both the coin show head or both show tail or one show head and one tail. A, H, 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 T, T, T. Next is theoretical probability. How to find the theoretical probability of an event? The probability of an event is the number of ways the event can occur. Favorable outcomes divide the number of total number. What is the theoretical probability formula? In general, probability of an event happening equals number of ways it can happen over total number of outcomes. Example, you can see the spinner's picture. Theoretical probability of spinning the spinner and landing on blue or B equals probability of B equals number of possible blue outcomes over total number of outcomes. For the blue color, there are 3 and there are 8 of the total colors. Example 2. There are 5 marbles in a bag. 4 are blue and 1 is red. What is the probability that a blue marble get picked? Number of ways it can happen is 4. There are 4 marbles. There are 4 marbles blue. Total number of outcomes is 5. There are 5 marbles in total. So, the probability equals 4 over 5 equals 0.8. Next is experimental probability. Experimental probability is found by repeating an experiment and observing the outcome. Probability of event equals number of time event occurs over total number of times. How to find the experimental probability of an event? Step 1. Conduct an experiment and record the number of times the event occurs and the number of times the activity is performed. Step 2. Divide the two numbers to obtain the experimental probability. Example, a coin is tossed 10 times. A head is recorded 7 times and a tail 3 times. So, probability of head equals 7 over 10 and probability of tail equals 3 over 10. Next example, Jane spun the spinner 20 times. Her result is shown in the table. You can see the table has a table of color and number. In the color table, there are yellow with 4 number, green with 6 number, and blue with 10 number. Experimental probability of spinning the spinner and landing on blue equals number of possible blue outcomes over total number of possible outcomes equals 10 over 20 equals 1 over 2. Next is probability of independent event. Independent event, the outcome of one event does not affect the outcome of the other. If A and B are independent events, then the probability of both occurring is probability of A and B equals probability of A times probability of B. Example, your boss to be fired randomly assign everyone an extra 2 hours work on weekend evening between 4 and midnight. What are the chances you get Saturday between 4 and 6? You can see this picture. There are 2 days on the weekend, so probability of Saturday equals 0.5. And times you want the 2 hours of 4 to 6 of the 8 hours of 4 to midnight. So probability of 4 to 6 equals 2 over 8 equals 0.25, and probability of Saturday and 4 to 6 equals probability of Saturday times probability of 4 to 6 equals 0.5 times 0.25 equals 0.125 or a 12.5% change. Next is probability of dependent event. Dependent event, the outcome of one event affect the outcome of the other. If A and B are dependent event, then the probability of both occurring is probability of A and B equals probability of A times probability of B given A. Example, a purse contains 4 $5 bills, 5 $10 bills, and 3 $20 bills. 2 bills are selected without the first selection being replaced. Find probability of $5 then $5. Solution, there are 4 $5 bills. There are a total of 12 bills. Probability of $5 equals 4 over 12. The result of the first draw affected the probability of the second draw. There are 3 $5 bills left. There are a total of 11 bills left. Probability of $5 after $5 equals 3 over 11. So, probability of $5 then $5 equals probability of $5 times probability of $5 after $5 equals 4 over 12 times 3 over 11 equals 1 over 11. The probability of drawing a $5 bills and then a $5 bills is 1 over 11. Next, example 2. Let's look at some experiment in which we can apply this rule. Experiment 2. Mr. Parietti needs 2 students to help him with a science demonstration for his class. of 80 girls and 12 boys. He randomly chose one student who came to the front of the room. He then chose a second student from those still seated. What is the probability that both students choose a girl? Probabilities. Probability of girl 1 and girl 2 equals probability of girl 1 and probability of girl 2 given girl 1 equals 80 over 30 times 70 over 29 equals 306 over 870 equals 51 over 145. Thank you for watching this video. Don't forget to like, comment, share, and subscribe. Bye bye.